Hi ladies and gentlemen, it's Mr. Green again. It's another in my series of geometry lessons, and I appreciate you being here. We should be completely through with Unit 4. We're into the third lesson in Unit 5 right at the moment, so make certain you're getting all those correct quiz corrections in. We're getting close to the end of the semester. We don't want to be falling behind on that. Due dates, we got things that are closing. We want to make certain we get all those things turned in because you don't want zeros being in the grade book out there. Okay? Let's move forward here. Today we're going to talk about a new topic. We're going to be looking at area still. But one of our issues is we didn't have area of all of the types of objects that are out there. We only had an area of some of the quadrilaterals. We didn't have all of them. And so what we want to do is we want to look at regular polygons and a concept called the apothem. Apothem. Apothem is a distance that goes from the center of the polygon to one of the sides, making a 90-degree angle. So you might call it the height of the or half of the height of the polygon, but that's pretty much what it is. It goes from the center to the side and it makes a 90-degree angle. That's called the apothem. That is just the word for it, okay? Don't try to confuse it with anything else. It came from some Greek that was being translated, and it's difficult to understand where it came from. But that's what it means, apothem. Now, what are we going to use that apothem for? Well, if you look at regular polygons, they can always be divided up into triangles because you can go from that center to each one of the vertexes and you'll get a bunch of triangles. How many triangles will you get? Well, it depends upon what type of an object it is. But if you go from this up center out to the side, this apothem represents the height of one of the triangles. Actually, it represents the height of all of the triangles, doesn't it? So if I take that height times the length of one of the sides, b, the base times the height. Come on, dyslexia kicking in here. Height times base. Okay? And since it's a triangle, I'm going to divide it by 2. 1/2 the height times the base, right? Well, then I count up how many objects I have. And in this particular case, I've got 1, 2, 3, 4, 5, 6, 7, 8 objects here. I'm going to just add this, or multiply it times 8, right? 8, because there's 8 of them. And that would tell me the area of this octagon. But you know what? If I multiply 8 times this base, that's the definition of a perimeter, because I actually found the distance all the way around, didn't I? So that would be a perimeter. So if I take the perimeter times that height, well, that height is also known as the apothem, and divide it by 2, or 1/2 of it, that's how we get the formula for a polygon. It's 1/2 the perimeter times the apothem. Does it just work on octagons? Nope. It actually works on any regular polygon. So would this work on a square? Yeah, it would work on a square. Would this work on a equilateral triangle? Yes, this will work on an equilateral triangle. Will it work on a hexagon? Yes, it'll work on a hexagon. Will it work on an octagon? I just showed it here to you on an octagon. Will it work on any regular object? Yes, it will work on any regular polygon. You'll be able to find the area of that regular polygon just by knowing the distance from the center to the edge. Let me show you an example. In this polygon right here, we've got 9.7 as the distance here. 8 is one of the sides. Well, I'm going to count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8. So my perimeter is going to be equal to 8 times 8, or 64. So my area of this particular octagon is going to be equal to 64 times 9.7, all divided by 2. I can't do that in my head because I'm not real good at my 9.7s. Those multiplication tables weren't ones that I actually memorized when I was a little kid. So I'm using a calculator to calculate that, and I got 310.4 as the area. Since it was in inches, it would be inches squared. Cool? And you look at what they did over here. That's exactly what they did. Okay? So let's move forward in this. Okay? Here we've got a pentagon. I'm going to do the same thing. 5 sides. 5 times 5 is 25, so my perimeter is going to be 25. So I'm going to take my area is going to be 25 times 3.4 divided by 2. And once again, I don't know my 3.4s that well. So 25 times 3.4 divided by 2 is giving me 42 and a half. So I got 42.5 inches squared. Hope you guys are seeing how I'm doing this. If you're not, make certain you go back and watch these recordings again and again and again until you get it. The Apothem becomes a very, very powerful tool for you. Okay? Oh my. Here they didn't actually give us the Apothem, did they? What type of an object do I have? I have a hexagon, and I'm going to divide this hexagon up into my triangles so that I can see what they look like. Okay? Now I know from studying hexagons already that if I take this hexagon, I can find this angle right here, can't I? That was n minus 2 times 180, going back to that old thing to figure out what the sum of the angles inside of the triangles were, right? So that'd be 4 times 180. And I'm going to divide that by 6 because there's 6 angles in the whole thing. So that means each one of these angles is 120 degrees. But you know what? This diagonal is actually bisected. So that means in each one of these triangles, I've got 60-degree angles in each one of the... Oh, wait a second. That means I got 60 degrees up here, too. Okay? And those are just the angles that are in here. If those are 60-degree angles, that means that's an equilateral triangle. That means that this is a 12 and this is a 12. Oh, we actually can find the lengths of those sides? Yes, we could. And you know what? I know a trick. It's called the Pythagorean theorem. I can find that apothem. Why? Because that will tell me that this one's 6, this one's 12, and I can use that 6 and that 12 and find the length of that other side. So 12 squared minus 6 squared gives me 108, and I take the square root of 108, and I get 10.39. 10.3, yeah, 39. So this side right here, actually, that apothem actually is 10.39 centimeters. I went through all of that just to find the apothem. Well, we do know the perimeter too, don't we? 6 times 12 is 72, so my perimeter is equal to 72. So my area is going to be 72 times 10.39 divided by 2. Or 374.12 centimeters squared. Hope you see what I did there. I mean, with hexagons, it's really kind of simple because we can use some of the things that we've learned about other triangles in the past and make that and work that out. This is something we're going to get to a little later on. Okay? Cool. Okay. having worked through that problem, I think the next thing we've got up here is uh, yep, another problem. And what they're going to show you here is even with multi-sided objects, many sides, you can still figure out the length of the sides. I'm going to take this area, I'm going to divide it by the apothem, multiply it times 2, and I will find that the perimeter is 36 centimeters. And then count the sides and divide by the 9 sides. 36 divided by 9 tells me that each one of these sides is 4 centimeters long. Okay? So I appreciate you being here. And if you have any questions, make certain you're coming to Toga and asking the questions. Otherwise, I will see you next time.